Hi, hello everyone. So good evening to all of you. In this session, we are going to see some important concepts of computer network subject with respect to GATE examination. And my motto in this session is, I just want to do with concept through questions. You can say that CTQ, which stands for concept through questions. And I'm taking the questions of GATE 2015 questions as well as GATE 2007 questions. Why I have chosen these 2 years? You know that in our previous session I clearly mentioned, previously IIT Kanpur have conducted GATE examination in these 2 years. So that is why my target is just I want to explain you some concept through some questions which are given which are part of this GATE 2015 paper and 2007 paper. Okay, right. So let's move the questions based on this. The questions based on 2007 paper. Let's say if you consider this first question, which is very simple question, it is based on TCP/IP reference model. This question is based on TCP/IP reference model. So if you recall TCP/IP reference model diagram, just by looking at the diagram, you can easily answer this question. So what is the diagram for the TCP/IP reference model? If you recall, we know that the TCP/IP reference model contains 5 layers. You can say 5 layers you are having. So what are the 5 layers? Or else some people used to say 4 layers. And as per the Cisco latest version, Cisco is saying that there are 5 layers as part of this TCP/IP reference model. So anyway, I just considering as per the textbook, I am considering 4 layers here. That is first one, host to network layer here, host to network layer, and next one we are having internet layer. So this is my internet layer, and this is what my transport layer, and this is what my application layer. So in TCP/IP reference model, we don't have presentation layer and we don't have session layer, right? So and this host to network layer corresponds to 2 layers of OSI reference model, that is physical layer and data link layer. So in our classes, we clearly define exclusively this data link layer for its internet applications. It is using 2 types of protocols. What are the 2 types of protocols it is using? One is PPP and another one is SLIP. You know that PPP, which stands for point-to-point protocol, SLIP, which stands for serial line protocol. These are the 2 protocols which are exclusively used by the data link layer for its internet applications. So if you look at the protocol on TCP/IP layer, so first PPP, if we consider, PPP belongs to data link layer. So that's why we can match this PPP to data link layer. So it means S goes to 3. S goes to 3 here. Okay. Then coming to internet layer. So as part of this internet layer, we are having the protocols such as ARP, RARP, and we have IP protocol, and we have ICMP protocol, and we have IGMP protocol. So these are all various protocols we have as part of network layer, right? So and BGP. So these are all part of our internet layer, right? Then if you consider transport layer, we are having the protocols called TCP, UDP, and SCTP. These are the 3 protocols that are part of transport layer. So if you verify TCP, so TCP is R goes to 2. So R2 is the next correct combination here. And BGP, if you verify, BGP is according to this internet layer it is. So BGP is part of internet layer, right? So it means Q goes to 4. Next. Coming to the application layer protocols, if you verify, as part of application layer, we are having protocols called FTP, we are having protocol called SMTP, we have the protocol called DNS, and you know that we are having HTTP, and we are also having TFTP, you can say TFTP, and we can also have a protocol called NNTP. So like this, we are having some protocols as part of the application layer. So if you verify SMTP as part of application layer, so that I can match this with the P1 itself. So P1 Q4 S3, P1 Q4 R2 S3 is the correct answer for this question. So very simple. If you recall the diagram of this TCP/IP reference model, you can easily able to answer this question. This is the question which we have in 2007 question. Okay, simple question. It is given 1 mark question, right? Right. Next, let's look into the next question. So this is the question which is based on CRC, right? So the message 11001001 is to be transmitted using the CRC polynomial, that is x cube plus 1, to protect it from errors. The message that should be transmitted is, so try to recall CRC concept if we consider. So CRC, it is having it is generating the redundant bits. It is generating the redundant bits with the help of modular 2 division technique. So what is the technique we are having? Modular 2 division technique. Modular 2 division technique is used by CRC to generate the redundant bits. So when it is division, we are having two important components we have. So what are the 2 important components? That is, first one, you can say that dividend. The first one is dividend, and the next one is divisor, and the next one is divisor. So these two are the major components of our CRC, right? So it means that in order to implement the CRC, we require 2 types of messages. One is M of X, I can say. One is called M of X, and another one is called G of X. So according to the question, M of X is given like 11001001. So M of X is already given 11001001, and G of X is given in terms of polynomial, that is x cube plus 1. So as our M of X is in binary, we need to convert this G of X into binary because it is in polynomial now. So you can apply this modular 2 division technique on both on both binary type of data as well as polynomial type of data also. So since M of X is already in binary format, we can convert this G of X also in terms of binary. So how we can convert a polynomial into binary? You know that as the maximum exponent of this G of X is 3, so that the G of X length is going to be 4 bit. So initially I can write all the 4 bits like zeros, and then I am positioning the X values like this: X power 0, X power 1, X square, and X cube. So as X cube is presented, I can write X cube is 1 here, and as X power naught is presented, I can write this one is 1. So overall, what is the corresponding binary value for this is 1001, right? This is one method, or else you can write like X cube 1 into X cube plus 0 into X square, because X square is not there, plus 1 into X power 1. X power 1 is also not there, so that is why it is 0, and 1 into X power naught. So like this also you can write, so that you are able to get 1001 as the G of X. So you know, according to the CRC, if the G of X length is n bit, then we need to append n minus 1 number of zeros to the M of X. So G of X length is here 4 bit, so that how many number of bits we need to append, in the sense 3 bits we need to append, 3 zeros we need to append to the M of X. So that's what I am doing here. So 1100 1001, 3 zeros are been appended, and this is what my M of X now. And what is my divisor now? 1001 is my divisor. So modular 2 division technique always concentrate on the MSB bit. So in my M of X, what is the MSB bit we are having? 1, so that the quotient is 1. 1 into 1001, which is 1001. So in between these two, normally we perform subtraction, but here we are performing XOR operation. So 0 1 1 0 0 0 1 0 1 1 1 0. This 0 gets cancelled, and this 1 we are bringing to here. So now MSB bit is 1, so that the quotient is also 1. 1 into 1001, 1001. So then performing XOR operation again, 1 1 0, 1 0 1, 0 0 0, 0 0 0, 1 1 0. So that this is cancelling, I mean this 0 is getting cancelled, and this 0 we are bringing to here. So now MSB bit is 0, so that the quotient is 0. 0 into something 0, so that 0 0 0 0. Then this is going to be 0 1 0 0. So this 0 gets cancelled, and this 0 we are bringing to here. Now MS bit is 1, so that the quotient is 1. 1 into 1001, 1001. So then this is 0, 0, 0 and 1. This 0 gets cancelled and this 1 we are bringing to here. Now MS bit is 0. So that the quotient is 0. 0 into 1001, which is 1001. Then this is going to be 0, 1, 0 and 1. Right? So if you verify here, the thing, so MS bit is 0 here, right? So MS bit is 0. So MS bit is 0 in the sense, you need to take the quotient is 0 only, right? So because MS bit is here 0, right? So let me make a correction here. So as MS bit is 0 here, quotient is also 0, right? So quotient is also 0. 0 into something 0 here. So this one is for this and this one is for this. This 0 is for this and this one is for this, and now quotient is 0, right? So then 0, 0, this is 1, this is going to be 1, right? So this is going to be 1, 1 and 1, right? So again MS bit is 0, so that quotient is 0, 0 into something 0. Okay, so let's say we are cancelling this 0 bit now, and we are appending this 0 bit here. Now again MS bit is 0, so that the quotient is 0. 0 into something 0. So 0, 1, 1, 0. This 0 gets cancelled and this 0 we are bringing to here. Now MS bit is 1, so that the quotient is 1. 1 into 1001, which is 1001. So now this is 1, 0, 1, 0. So this 0 gets cancelled and this 0 we are bringing to here. Now again MS bit is 1, so that quotient is 1. 1 into 1001, which is going to be 1001. So then this is going to be what? So 0, 1, 1, 0, 0, 0, 0, 1, 0, 1, 0, 1, 1. So as you know that all the bits are being processed now, so that this 0 we can ignore, and as no bit is being left, this is going to be my reminder. So as you know that in CRC, before transmitting the data, whatever the number of n-1 number of zeros we have appended to the m of x, that n-1 number of zeros must be replaced by CRC here. So it means that you are sending the message format that you are sending to the receiver is m of x plus CRC. So m of x is these 8 bits like 1100, 1001, and what is after replacing these 3 zeros with this 011, you are going to have 011 here. So this is the message that you are transmitting to the receiver. So verify what is the option that is matching. You can verify it is matching with option B. So and look at what, without solving this question, we can also predict the answer here like this. How? See, what is the length of m of x here? The length of m of x is 8 bit. And what is the length of the CRC is going to be? If the g of x is g of x is n bit, then the CRC is going to be n-1 bits, correct? So it means that 8 plus 3 bits, total 11 bits data you are transferring to the receiver. So among the options, if you verify, 11 bits is violating in option C and option D. So that these two can be ignored. That's it. So the answer is among A and B. A and B. You know that this A is, this is m of x plus, this is 3 zeros. It means that n-1 number of zeros, n-1 number of zeros. It means that this is a format you can see at the sender itself before starting off modular 2 division technique. And of course, there is a possibility that the remainder at the sender may contain 0. Fine, that is also possible. But mostly this format we can see before starting off modular 2 division technique at the sender side. So that's why we can have in defense with respect to option A. So confidently we can pick up option B is the answer for this. So this is the way how we can predict the answer for this without solving. Okay, right. So I hope you are clear with this. So CRC, what you are doing? So m of x plus n-1 number of zeros is it is the format of your dividend. And after generating the CRC, after generating the remainder at the sender is called as CRC. This CRC you are replacing these n-1 number of zeros with this CRC, so that the message format that you are sending to the receiver is m of x plus CRC. So this is the way how you can handle this question. Okay, right. So let's move to next question. So this is the question from IPv4 addressing. Have a look. The address of a class B it is mentioned, the address of a class B host is to be split into subnets with 6-bit subnet number. What is the maximum number of subnets and the maximum number of hosts in each subnet it is possible? So you know that class B it is. So what is the class B? Default mask address verify. Default mask address of class B is 255.255.0.0, right? So as it is saying that 6-bit subnet number, it means that we need to append. Actually, as per the DMA, we are having 16 ones. But now you need to append 6 extra ones to the 16 ones, so that you are going to have 22 ones in your mask. So what is that mask is called? Subnet mask address. So now what is the subnet mask address after considering this 6-bit subnet number? Then this is going to be 255, 255 and 6 times of 1, 00 and 80. This is going to be your subnet mask address after considering this 6-bit subnet mask. So if you verify, as per the class B, 2 bytes of NID you are having, 2 bytes of NID, 16-bit NID and 6-bit SID, and total this is 10 bits are going to be HID. So what is the length of HID? 10 bit. What is the length of SID? 6 bit. So SID length is 6 bits and HID length is 10 bits. Correct? So if HID length is 10 bits, then how many number of hosts per subnet we can create? So therefore the number of hosts per subnet is equals to, you know that number of host case is always 2 power n minus 2, because host ID portion contains all zeros, host ID portion contains all ones, is special addresses. They are network address and broadcast address. So that's why we won't consider them, right? So the formula for this number of hosts is always 2 power n minus 2. So as n is 10 bit here, 2 power 10 minus 2, which is going to be 1022. So among the options, if you verify 1022, you can see in only option C. But you can say that SID length is 6 bit. So if length of the SID is 6 bit, then the number of subnets. So number of subnets is equals to, see, number of subnets case is always 2 power n. It is not 2 power n minus 2. So as per the latest routers from the Cisco, they are accepting all zeros subnet and all ones subnet also. So the total you are having 2 power n number of subnets. There is no 2 power n minus 2 with respect to number of subnets case. So as the length of the subnet ID is 6 bit, you can say that it is going to be 2 power 6, that is going to be 64 subnets. Maximum these are 64 subnets, among them we can use 62 subnets. So as per our requirement, we can use 62 subnets, right? So with that 64 subnets is the maximum number of subnets, and 1022 number of hosts per subnet maximum we can have. So this is what exact answer, but among the 64, you can have 62 number of subnets you can usage. So that's why option C can be the answer here. So 64 and 1024, it is not at all possible. Reason host ID portion contains all zeros and all ones is not acceptable, right? And this is not at all, this count is not at all possible with respect to number of host case. So we can easily ignore option A and option B because of this number of subnets, number of host case. And here also number of host case, it is always 2 power n minus 2. So when it is 2 power n minus 2, obviously it is going to be 1022, not 1024, right? So that's why option D also can be ignored. So only option C is the appropriate answer for this. So I hope you are clear with this, right? Next, and mind that one point, if you want to calculate the number of subnets, compulsory the question should give either class of IP address or else the IP address. If the class of IP address is not given, if IP address is also not given in the question, then you cannot find the number of subnets per network. So if you want to find out the number of subnets per network, compulsory the question should have IP address, either IP address or class of IP address. Compulsory it has to be given, because number of subnets is depending on the extra number of ones that are added to your default mask address to form a subnet mask address. So extra ones we are speaking. So that's why compulsory the question should have either IP address or the class, okay, in the case of number of subnets. But in the case of number of hosts, it is not necessary. Number of hosts is always concentrating what? Number of zeros. Number of zeros it is concentrating. But here it is extra ones it is concentrating. Okay, so that's why number of subnets case you have to consider extra ones. Okay, so it means you have to, I mean the question should have either class or the IP address. Compulsory it has to be given. Otherwise, the question is ambiguity question. Okay, right. So let's look into the next question, which is part of this 2007. So this is the question you have from sliding window protocol. Very good question and beautiful question it is. So it is saying that, see, it is clearly mentioned minimum number of, we need to find out minimum number of bits per sequence number field in a frame for maximum utilization. It is clearly mentioned. For maximum utilization it is mentioned. For maximum utilization it is mentioned. Okay, so when it is for maximum utilization, you know that maximum utilization in the sense efficiency is given as 100%. So when efficiency is, when in sliding window, when the efficiency is in sliding window, you know that in sliding window, if efficiency is given as 100%, then what is the condition you have? W is equals to 1 plus 2A. So this is the origin statement to answer this question. How it is W is equals to 1 plus 2A? What is the formula for sliding window efficiency? How we are deriving? The derivation also we clearly explained in our classes, right? So this one I am going to see where this, you know that where this A is, what is the A value? TP by Tx. TP by Tx. So now look at, so first I am considering the distance between two stations is M and N, between two stations M and N is L kilometers. It means distance value is given as L. So D is given L kilometers. L kilometers. All the frames are k bits long. All the frames are k bits long. So length of the message we are considering that k bits. The propagation delay per kilometer is given t seconds. So per kilometer it is given. So TP is given t seconds per kilometer. But what is the length of the channel you have? L. So that the TP value is going to be LT. LT. TP value is going to be LT seconds, you can say. LT seconds. Next. Bandwidth is given. What is the bandwidth value? R bits per second. So bandwidth B is equals to R BPS, bits per second. So from these two, we can calculate the Tx value. So Tx is equals to L by B. What is the L by B here? L is K and bandwidth is R. K by R is the Tx value. So from these two, we can calculate the A value. What is the A? TP by Tx. So TP by Tx in the sense what? TP is LT by Tx is K by R. So which is going to be LTR by K. LTR by K. This is what your A value. So now simply substituting that A value in this expression. So therefore, W is equals to 1 plus 2 into LTR by K. Then if you simplify this expression, you are going to get K plus 2 LTR by K. This you will be getting. And you know that in order to find out the number of bits, minimum number of bits in the frame sequence number field, whatever the window size we are getting, that you need to express in terms of powers of 2. So then I am equaling with this, with the powers of 2. So 2 power n is equals to K plus 2 LTR by K, where this n is number of bits in the frame sequence number field. So therefore, n is equals to, what is the value of n now? Therefore, n is equals to log 2 LTR plus K by K base 2. This is what the value of n. Right? So which is matching with your option C, 2 LTR plus K by K. So option C is the answer for this question. So if the question does not given this particular value, this particular one, if the question does not given, let's say if the question is not given this particular line, what is it in line this maximum utilization, if it is not given, then you can get the answer as option B, because to find out the number of bits in the frame sequence number field, we are having a sequence of steps which we have discussed in our classes. So if we follow those sequence of steps, we can get option B as the answer here. Okay, but here it is clearly mentioned maximum utilization. That is a twist statement here. So since it is maximum utilization, you need to start answering the question from this particular line. That is, if efficiency is 50%, then what is the condition we are having in sliding window is W is equals to 1 plus 2A. So from this, if you start solving this question, you can get option C as the answer. Okay, so I hope you are clear with this. Let's move to next question. Yeah, so this is the question we have in 2015. So in 2015, we have this question like, which one of the following fields of an IP header is not modified by the typical IP router, right? So if you verify checksum, you know that IPv4 datagram header format, if you recall, IPv4 datagram header format, if you recall, we have a field called header checksum, right? That is IPv4 is calculating the checksum for only header. But if you consider TCP and UDP, those two protocols are calculating the checksum for both header and data. But IP is calculating the checksum for only header, right? So, and look at this TTL, time to live. So this particular time to live is decremented. It is decremented. TTL value is decremented. It is decremented by every visited router. Every visited router, every visited router and destination also. So these two are decrementing this TTL value. So it means that obviously we can observe that as the router or destination is being decrementing the TTL value by 1, we can say TTL value gets changed. But here not modified. We need to find out the not modified. But TTL value is getting modified. So hence option C is not an answer for this. Next, if you verify checksum, see, you are calculating the checksum for the header. In the header, do you have this TTL field or not? Yes. So when you have this TTL field, let's say if you consider IPv4 datagram header format, okay, IPv4 datagram header format, if you consider, you can draw the diagram for this like this. So for example, if you consider this is the header format of IPv4 datagram header. So this is the header part and this is the data portion. And here we have the header fields like this. So the first field we are all know that version field, and the next field we are all know that HELEN field, and the next field we are all know that TOS field, right? So, and these are all the fields which are part of our header, and this is your total length. Next, second row, if you verify, second row is like, you know, that identification field, okay, and then you are having flag section, and then you have fragmentation offset. After that you have, what are the two fields what are the next two fields we are having? We are having TTL field here, which is 8-bit, and we are having protocol field also. After this we are having here header checksum. This is the header checksum field. And then we have source IP address. So this is a source IP address field. And this is the destination IP address field. So the next field we are having destination IP address. And the last one is we are having options field. So this is what your IPv4 datagram header format. So if you write the fields sizes, this is 4-bit field, This is also 4-bit field. This is 8-bit field. This is 8-bit field. This is also 8-bit field. This is 16-bit field. Right? So this is 3-bit field. Flag section is 3-bit. And fragmentation offset is 13-bit field. Header checksum is 16-bit field. Source IP address, it is 32-bit field. Destination IP address, 32-bit field. And options field is 0 to 40 bytes. And at the end we are having here header. Header, if we consider, it is a size of 20 bytes to 60 bytes. 20 bytes to 60 bytes. So this is what your IPv4 datagram header format. So here you are calculating the checksum for header. So in this header, if any field is being modified, obviously the checksum also gets modified. So that is the reason we can say, checksum also gets modified. So checksum also gets modified. It is also modified because, what is the reason? Because TTL value is changed. TTL value is changed. As the TTL value is modified, this checksum value also gets modified. But source IP address never modified. It never gets modified. Source IP address never gets modified. And you know that the source IP address remains the same. It remains the same until, during the entire travel between the source to destination. During the entire travel of the packet from source to destination, the source IP address or the destination IP address field never get changed. They remains unchanged. Okay. So hence you can say option B is the answer for this. Obviously option A is not answer because TTL value is getting changed. Obviously checksum also gets changed. Then coming to this total length of the field, this length of the field, if you are doing, if you consider a fragment, further fragment, if you consider a fragment, again there is a possibility that that particular fragment again gets further fragmented. Then there is a possibility of total length also gets changed. So that's why this is also not an answer for this. So only option B is the answer for this. Okay. So if you want to answer this question, compulsory you should aware of this entire header format along with the sizes and the functionality of each and every field of IPv4 datagram header format. Okay, right. So let's look into next question. So coming to this question, this is from TCP IP reference model. Verify. In one of the pairs of protocols given below, both the protocols use multiple TCP connections. Multiple TCP connections between the same client and the server. Which one is that? So if you verify, it is mentioned HTTP and FTP, HTTP, Telnet, FTP and SMTP and HTTP and SMTP. So this is, so if you consider FTP, so what are the features of FTP? Try to recall. FTP is using port number, TCP port number 20. FTP is using port number 20 and port number 21. Both it is using, right? Port number 20 and port number 21. Both are using by this FTP protocol, right? FTP is using these two port numbers of TCP. These two port numbers are of TCP only. Right, so here port number 20 is for data transfer and port number 21 is for connection control, right? So it means that whatever the connection control we are having, that connection control we are using persistent connection. So port number 20 and port number 21, if you consider, this is for connection control and this is for data transfer. For data transfer we are using non-persistent connections, and for connection control we are using persistent connections. So you know that persistent connection means what? We can transfer multiple packets or else multiple objects in the same connection. That is called persistent. But in the non-persistent, for every object, we need some different connection. So persistent connection, the connection establishment, whatever the connection control we are having between the client and server. So if you consider this is the client, FTP client, this is FTP client, and this is your FTP server. For example, it is FTP server, this is FTP server. So Port number 21, if you consider port number 21 we are using for connection control here. This connection control we are using non-persistent connection. So this is this non-persistent connection means, this is actually persistent connection, sorry. Whatever the connection control we are using, this is persistent connection. This remains same, but when we are having, this is port number 21 and port number 21, but when it is having port number 20, this port number 20 is being on and off. Transmission, port number 20 gets open, close, open, close. So open means whenever you are about to start transmitting, it gets open, then after transmission of the object, it gets closed. So it means that here, if I am having 6 objects, so to transfer these 6 objects of data, then how many number of persistent connections I require, how many number of non-persistent connections I required, in the sense 6 non-persistent connections, because non-persistent connection is what? Per connection you can transfer only 1 object. So now if you want to transfer total 6 objects, then total number of TCP connections you required, here is how many? 7 number of TCP connections. Why? So 6 is non-persistent connections and 1 is persistent connection. So obviously FTP is using multiple number of TCP connections, right? And HTTP, if we verify, HTTP is a hypertext transfer protocol that HTTP is using port number 80 of TCP, port number 80 of TCP only. This is also TCP port number 80, right? So this HTTP also using persistent connections as well as non-persistent connections according to HTTP versions. So one version of HTTP is using persistent connection and another version of HTTP is using non-persistent connection. So it means that HTTP also can use non-persistent, means for accessing of every URL address, you can open new connection. Let's say if you consider your Google Chrome, in the Google Chrome, if you open in a tab, in one tab, if you open www.google.com, in the same tab, are you able to open crickbus.com? No. So you need to open next tab. In that tab, you can open crickbus.com, correct? So in the same tab, you cannot have you cannot have 2 URL addresses access. So it means that for accessing 2 URL addresses, again you need to open one more tab. So it means for every URL address, you are accessing one tab. So new connection is being established. So that HTTP also uses multiple TCP connections and FTP also uses multiple TCP connections. Hence, option A is the answer for this question. So you need to have some theory related to this particular question. I mean, TCP IP reference model theory, if you are aware, you can easily handle this question. What is the persistent connection? What is non-persistent connection? What is the port number of respective protocol? We have discussed in our classes about the couple words. Couple word in the sense persistent and non-persistent. It is a couple. Similarly, push and pull. Similarly, in-band and out-band. Stateful and stateless. So 4 pairs, 4 couple words we have seen. 4 pairs of word. Stateful, stateless, push and pull, in-band, out-band, persistent and non-persistent. So we discussed everything in our classes. We have defined everything in our classes, right? So this is what the description about this particular question. Option A is the answer for this. So let's move to next question. So this is the question we have on stop and wait protocol. So suppose that the stop and wait protocol is used on a link with a bitrate of 64 kilobits per second and 20 milliseconds propagation delay. Assume that the transmission time for the acknowledgement and the processing time at the nodes are negligible, then the minimum frame size in bytes, minimum frame size in bytes, we need to calculate. In bytes, it is clearly mentioned. In bytes, to achieve a link utilization of at least 50%. So you know, in stop and wait, we clearly defined one point. In stop and wait, if you recall, in stop and wait, for efficiency of 50%, we have a condition that is L is equals to B into R. So how we are getting this condition, that is also we discussed in our classes, right? So Now, this is the core point to answer this particular question. So anyway, let's collect the data here. Bandwidth is given 64 kilobits per second. Bandwidth is given. Propagation delay is also given 20 milliseconds. So TP is also given 20 milliseconds. Right? So therefore, what is the L value? This is what it is asking. So now, as efficiency is 100%, L is equals to B into R. B is 64 into 10 power 3 plus B into R. You know that RTT, if TP is 20 milliseconds, then your RTT value is going to be how much? 40 milliseconds. You know RTT is equals to 2 into TP. So 40 into 10 power minus 3, and this is bits. This is in terms of bits. 10 power minus 3 bits. Because this is bandwidth bits per second, and this is in terms of seconds. Seconds gets cancelled, bits can be remaining. So 10 power 3, 10 power minus 3 gets cancelled, 2560 bits you can find. But the question is asking about bytes. So simply you can convert these bits into bytes. So for that, what you have to do, you divide this 2560 by 8. Then this is going to be 320 bytes. So 320 bytes is the answer for this question. Just convert this 8 to 2560. If you consider 3 is 16, 2 is 16, right? So 320. So 320 is the answer for this question. Okay. Right. So simple. These are all formulas and concepts we have discussed in our classes. Please recall the concepts and please try to revise. This is the moment for revising of all the concepts, right? Next. Let's look into the next question. So this is one question which is based on your aloha. So consider a LAN with 4 nodes, S1, S2, and S3 and S4. Time is divided into fixed slots, and a node can begin its transmission only at the beginning of the time slot. So based on this line, you can easily predict that this particular question is based on which concept? Slotted aloha. Of course it is aloha, but you know that aloha is 2 types, slotted aloha and pure aloha, right? So that slotted aloha, this question is based on this slotted aloha, right? So a collision is said to have occurred if more than one node transmit in the same slot. The probabilities of generation of a frame in time slot by S1, S2, S3 and S4 are 0.1, 0.2, 0.3 and 0.4 respectively. The propagation delay of sending a frame in the first slot without any collision by any of these 4 stations, is dash. So if we consider 4 stations we are having, S1 is there, what is the probability for S1? 0.1. S2 is there, what is the probability? 0.2. S3 is there, what is the probability? 0.3. S4 is there, what is the probability? 0.4. Right? So as it is clearly mentioned, the probability of sending a frame in the first slot without any collision by any of these 4 stations. So we need to consider all the probabilities of all the stations. Like if you consider first S1, if I want to allow only S1, then the probability is 0.1. And I should not allow S2, S3, S4 for avoiding the collision. So it means that what is the not probability for S2? As the probability for sending a frame for S2 is 0.8, for not sending 0.8, right? So this is 0.3, for not sending 0.7. This is S4's probability is 0.4, for not sending it is 0.6. This is the probability for S1 to generate the frame in the first slot. Then in the same way, we are going to consider S2 also. So we should allow S2, that's why 0.2, and we should not allow S1, S3 and S4. So that for not allowing S1 is 0.9, for allowing S2 is 0.8, for not allowing S3 station is 0.7, for not allowing S4 station is 0.6. Then this is what the probability for S2 exclusively. This is what the probability for S2. Then S3 also, because it is clearly mentioned by any of these 4 stations. Any station we can allow to transmit, right? So that's why we need to consider all the 4 stations probability. So if you consider S3, this is the probability for S3 to generate the frame. But S1 should not allow. It means that 0.9 is the probability for S1. 0.8 is the probability for S2 for not sending. for not allowing a frame to send in the first slot by S2, and S4 we should not allow, so that the probability for not sending a frame by S4 is 0.6. Then we are having the last station, that is S4. It is allowed to generate in S4. S4 is allowed. 0.4 is the probability, but remaining 3 stations are not allowed to transmit the frame, so that 0.9, 0.8 and 0.3, 0.7. So if you consider these things, by doing this addition operation, at the end what you are going to get 0.4404. So this is the probability of sending a frame in the first slot without any collision by any of these 4 stations is 0.440. So 0.440 is the answer for this question. This is the answer for this question. Okay. So like this, you are having some other questions also based on this computer network subject in our previous papers. See, if you are capable of solving the previous year gate questions, then I can say that different models you have touched. Getting my point? So different models you have done. So it means before attending to the examination, you please revise the concepts again and again by solving the previous year gate questions. So previous year gate questions can give you the revision of all the subject, entire subject. So my suggestion is, before appearing for gate examination, make ensure that at least 2 to 3 times of all previous year gate questions, at least 95% of all previous year gate questions, you should be in a position to solve them. Okay, so I hope you feel this session is helpful. Thank you. All the best for your examination.